Hello everyone, this is How I Love Geometry. I'm Mr. Cao. This problem is from 2013, Aime1, problem number 9. A paper equilateral triangle ABC has side length 12. The paper triangle is folded so that vertex A touches a point on side BC, a distance 9 from point B. So let's draw the scratch diagram. Right? Okay. That's the equilateral triangle. So, and all of them. And so side length is 12, right? And the paper triangle is folded so that vertex A, this is vertex A. Now, vertex A is folded. So that's, we need a equilateral triangle because in equilateral triangle, everything is easy. We can find special degree right triangles. Here is 30 degree, here is 60 degree, right? And is 12, and so this is 6, and 9 must be midpoint of here. So when I draw, this is A, now I write it A prime. Here is A. And we can connect this, right? We connect this one because we fold. When we fold it, and when you fold here, for example, if here, and this will be here. So it's an isosceles triangle. If it's isosceles triangle and this line will be perpendicular bisector, right? So I will draw here. So that's original A, now A prime. So I will use that's A prime. Here is new A, B, C. Let me see, D, E. The problem let us to find the length of the line segment along which the triangle is folded can be. So it fold from here, right? Now this part is fold along this segment. That's the problem talking. We will find DE, right? And DE can be right like this form, m times square root of p over m. So we will find m plus p. So that's, I want to restore the equilateral triangle. I think it's the most important idea to solve this type of problem. All the problems inside the equilateral triangle, it will be easy because we can easily define. For example, here you will find a lot of special degree right triangles, right? And easily to get this. So here is 6, here is 9. The problem talks new A come here. So this is 3, and that's a fold. Now that's a fold part, right? We know this part congruent to this. I mean D A prime congruent to DA because it's a fold over here. And this, and A prime E congruent to AE, right? So this A prime DAE is a kite. And so diagonals, they will perpendicular each other, and this is, and DE is the perpendicular bisector, and so all of here. Now the problem will become easier because we restore the equilateral triangle. Because this is 30 degrees, so I can say, let us suppose this is angle alpha. So this degree will be 30 plus alpha. And this angle will be what? This angle will be 30 minus alpha, right? This angle. And now this is a right triangle. We know it's 30, 60, 90 degree. If this 6, this is 12, also 12, 12. So we can easily know A prime, A, B, C, D, E, F, D, E. So here is F, here is G, here is H, okay. And A prime F, the height of that, it will be 6 square root of 3. And this is 3, FA is 3. So we can easily get A prime A will equals square root of 6 square root of 3 squared plus 3 squared, so equals square root of 36,108 plus 9,117. 117 is 9, so it will be 3 square root of 13, right? 9 times 13 is 117. Okay, so we know, now we know A prime H will 1/2 of 3 times square root of 13, right? So this will be 3 over 2 square root of 3. Okay, so we can go ahead. And now, because we want to find the DE, so we can use got this two part. I mean, I can use DH plus HE, right? If I say this is X, this is X, and this is Y, and HE is Y. These two parts are in the triangle, in the right triangle. So right triangle, we know A prime and A prime H. So we can use the trigonometry here. In the triangle A prime DH, this is a right triangle, right? So the angle 30 degree plus alpha, this angle, we can use tangent 30 degree plus alpha, this angle, to, because we know A prime H. So if we wanted to get X, I mean DH, right? So we know tangent alpha equals X over A prime H. So X will equals A prime H, and A prime H we know. And if we got a tangent 30 plus alpha, then we will find X. The same way we can find Y, right? Because Y can equals A prime H times tangent 30 degree minus alpha. And we know, if we familiar with the formula for tangent alpha plus beta, then we can easily to get, because we know tangent alpha equals in the triangle A prime F A. The triangle, that's a right triangle, right? It's a right triangle. Right triangle A prime F A. This is 3, and this is 6. This is 6 times square root of 3. So we know that tangent this will be 3 over 6 square root of 3 is square root of 3 times square root of 3. So we can cancel and got this is square root of 3 and cancel this. So square root of 3 over 6. That's the tangent alpha. We know tangent 30 degree is square root of 3 over 3. Now we will calculate this one, these two angles tangent value. So tangent 30 degree plus alpha equals tangent 30 degree plus tangent alpha 1 minus tangent 30 degree times tangent alpha. So it will be right plus this one, this right, and 1 minus, so that's square root times square root is 3 over 3, so 1 minus 1/6, so equals 5/6, and here is in 1/2 of square root of 3, so it will be 5 and times 6 and times 6 and times 6, right, and 3 times square root of 3 over 5. Now we got this one. Also, it's the same way we will calculate the value of tangent 30 degree minus alpha. So the formula will be tangent 30 degree minus tan alpha 1 plus tan 30 degree times tan alpha. So is square root of 3 minus square root of 3 over 6. So 1 plus, right? So that's 1/3 minus 1/3, that's 1/6 of square root of, and 1, we know this is 1/6, so 7/6 over 6, so is 7 square root of 3. Okay, now we can go ahead for this one. Because we want to find x plus y, that's what we need, right? dE equals x plus y, x plus all of them have this, and a prime of this one is, a prime of h is 3 over 2 square root of 13, then times this one plus this one, it means 3/5 square root of 3 plus 7 square root of 3. So we will get how much for that? 2 the square root of 13. So 35. That's 35, right? So 21 plus 5, then times square root of 3. So is 3 square root of 3 times, that's 26. Here is 2 times 35, then times square root of 3. So here it must be 13. So how much for that? Now we've got as 39 times this, also square root of 39, and this is 35. So m plus p equals 39 plus 39 plus 35, so equals 78 plus 35. So 113 done. Okay, this problem is not, I don't think it's very hard. It's a little, just a little complicated. If we know how to use trigonometry, yeah, it will become simple. And I always think when we got the problem about a equilateral triangle, we should restore the equilateral triangle, because in a equilateral triangle, all the problems will become simple because we can easily got a special degree right triangle, and we can easily got some angles trigonometric value, and we can use the trigonometry formula to find what you want. So I hope you can enjoy it. Thank you.